So, are we getting enough sleep? That's the question here, right?
Definitely not.
Definitely, that's a no-go, right? It's recommended that teenagers get 8 hours of sleep. I believe my stats students get less than that. To test the belief, she takes a random sample of 10 students in class. You see how this is getting repetitive a little bit? The skill sets are the same. We just switched to t values now instead of z because we switched to means. Okay? All right. Questions about this one? No? There's our conditions. We don't need to rewrite them. They're already there, right? T statistic and p-value. Remember degrees of freedom if you needed it. If you use the TCDF feature in your calculator with the boundaries and stuff like that, you would need your degrees of freedom, which is just n minus 1. But if you use the t-test, you don't need to worry about that. If you do t and you show your work here, which I hope you do, x bar minus mu over s divided by the square root of n. You don't have to use the symbols, just put the numbers in the right locations. All right, let's see if we can knock this puppy out. 10 minutes. According to the AAA Foundation for Traffic Safety Americans Driving Survey, U.S. drivers spend on average 51 minutes behind the wheel each day. And a researcher believes this is an overstatement. It seems like an important word. To investigate, a sample of 75 drivers were selected. Study revealed the mean time behind the wheel for the 75 was 46.4 minutes with the standard deviation of 18.8. Is there convincing evidence that the mean time behind the wheel is less than 51 minutes? All right, let's see. Now it says use alpha 0.01. This is different, isn't it? A little bit more strict guideline here. So the parameter, what is it? The mean time behind the wheel for U.S. drivers. Okay. The null is, the claim is it's 51, right? But what does our statistic give us evidence of? 46.4. So there's evidence that's 46.4. So we're going to test that at an alpha of 1%, so 0.01. It's going to be harder to reject the null this way, isn't it? But maybe we will, maybe we won't. Name of the procedure. This is a one sample t-test. T-test. Let's knock out these conditions. Was it a random sample? Okay, so we can say it's stated. Where n was how many? 75? All right, then let's think through this. Is 75 less than 10% of all U.S. drivers? Yes. So sure. What about normal? Can we use our favorite CLT here? Yes. Since 75 is greater than or equal to 30, by the central limit theorem, we're good. We know it's normal. All right, so if I'm going to do my formula work here, I'm just going to put it up here. It says that the mean of the sample was 46.4 minus 51 over the standard deviation of 18.8 divided by the square root of 75. Now, I'm going to use my calculator to save time. I use the stats mode on this one because all I have to do is enter my mean and my standard deviation and my sample size. And I get a t-statistic of negative 2.119. So visually, we're talking down here. And the p-value comes out to be 0.0187. Okie doke. Can we come up with the conclusion on that? Yeah. Okay, so we could start with sense, 0.0187. Oh, that's greater than 0.01, isn't it? What does that mean we're going to do? We failed to reject the null. So do we have convincing evidence? No. We do not have convincing evidence that, and notice this, I'm going to restate the alternative still. The true mean, what is it, time behind the wheel of U.S. drivers is less than, oh, I messed up, didn't I? 51 minutes. Did y'all catch that? I put 50. I didn't use the same numbers in my null and alternative up here. Have to use the same numbers. Sorry about that. You okay? How do you feel about it? It's okay?